This is the work solution to EP Sheet 6, question 1.6. So this question involves gauge pressure as well as absolute pressure. The main difference is if you measure something, it tends to be calibrated in some sort of way, and it tends to not necessarily be an absolute value, if that makes sense. So if you measure, let's say, the velocity of a car, realistically that car is on the planet Earth, which is, moving around the sun. So its velocity is actually greater than what you might assume it to be. So even if the car's parked, its velocity might say 0 miles per hour, but we know it's actually moving faster than that. So the gauge value for the velocity would be whatever the car speedometer says, but the absolute value would actually be a lot greater than that. It depends on how fast the Earth's rotating, how fast it's going through space and everything like that. So that might give you an idea for how to solve this question. So if we just say that the gauge pressure is equal to the density multiplied by gravity multiplied by the height, but then we say it's negative, it will give us a value for what we might read on the gauge. So the thing is, the reason we say it's negative is because it says in our question that it reads below the atmospheric pressure. So that's why it's negative in this case. If for some reason the question said that it just had a value above atmospheric pressure of this amount, then it would just be the gauge pressure is equal to density multiplied by acceleration due to gravity multiplied by height. The reason we have this negative sign is because the question tells us it reads a negative value on the gauge. Okay, so how do we work out the absolute pressure? Well, the absolute pressure is basically the difference between the atmospheric pressure and our gauge pressure. So we've got here absolute pressure is equal to atmospheric pressure minus gauge pressure. So I'm just going to zoom out a bit so you can see the whole thing at once. But that's basically how you solve this question.